Hello.
Hi.
Hi, how are you?
Good morning.
Morning.
How are you?
All right, so let's give their update first.
I think Lalith can go first. I'll wait for Sarrah to join in.
Okay.
Yeah. So I think it's very yeah. So I have been writing the work on this documentation part of the work that I have been doing so far. So so I have written the introduction and previous literature part. So in this, I see. I have a certain view while writing these two sections. So how I divided was initially I thought of writing first about the C. elegans embryogenesis and how important it is to understand the significance of it. The second, I wanted to write down what are the different type of neural networks and like the hypergraph or the graph neural networks which actually were devised for a couple of period of time, and the given the properties of like hypergraph neural networks and all, how it actually impacted into developing the embryogenesis of C. elegans. Have anyone tried yet? And what is the significance? And I have write it down in the literature. So I'll slowly walk down to each of the paragraphs, and I have noted the contribution where we actually are ahead, and what are the novel parts that we are actually contributing into this one. So first, I'll start with this introduction part. So here I introduced fairly enough, saying that uh, I should I read through the thing entirely, just for our.
Yeah, just give some highlights for each part if you wouldn't mind.
Yeah. So in the first paragraph, what generally it details about is we talk about like how C. elegans is good and what kind of data that we have, how the spatial information is useful, how our lineage information is useful, and why are these biologically meaningful. So when we try to extract these information, and this becomes a full good data platform, and which is like open source to us anyway. And what can we use? And based on this data, what can we actually use the correct network to evolve and understand the developmental characteristics during the embryogenesis. So in the next part, we talk about how do we capture the higher order interactions in this bigger network. Suppose it starts from a time point 0 and slowly that evolves. So during this evolution, at each time point, the graph actually connects and actually fuses along according to our paper that you have written on anastomosis of hypergraphs. So is that actually group pattern that we actually see during this, and how do we gonna see, and if we're gonna see, why our hypergraphs are actually useful to do that. So that part I have noted down, and also I have noted some of the papers which actually showcase that. Last week I have attached the two papers, right? So where they have used to understand tracking cell position tracking using hypergraphs. So like how different type of works have been using this part, and how we can leverage to develop our own method. So that is more of introduction, and why this is like very useful, and why is it biologically more plausible. So yeah. So again, related works goes like, okay, these people have done this way. Like how emergence of C. elegans has been done, starting from the Silston work, and later we talk about some of the important discoveries in the graph and hypergraph neural networks. So starting from GCN, hypergraph GCN, that and all, and then we jump into the hypergraphs which have been used to C. elegans. I shared two of the papers previously, right? So how do they exactly do, and what do they do? So and they use like higher order geometry and combinatorics in order to understand the embryogenetic volumes that have been present in the hypergraphs, and how do they actually do that. So that I have been noted. I have described, and also finally I have written that where does actually our motivation come from. So that I have got from the paper that you have actually written in 2023 about hypergraphs. So bringing all those things together, we made a contribution list where this is what we think. So see, we have certain gaps and we have some insights when we are developing hypergraph neural networks, and in which our main characteristics is to understand the group-wise connection that actually brings the lineage and also spatial structure together. One, and the second is it has a little bit of heterogeneity and size variant hyperedges. So how do we bring them together? And this is a temporal structure, so it actually grows from time point 1 to time point t, suppose. So during this, how do they actually split, and how do they dissolve, and how do they actually bring the grouped characteristics? So that we're gonna observe. So I think the first two contributions that are actually what I have accomplished, but the third I have to do. So what we have seen is till now is we have used a unique neural network, which actually does this, tries to understand the spatial and the structural, the lineage information. Then the second step is we have a visualization tool where we can understand that what the neural network is actually trying to understand. And using that visualization tool, we can see in the embedding space how this neural network learns the entire topology of the data, the embryogenesis. So while understanding the topology, the next part is, can we see any emergent structural patterns and certain patterns that we actually see? There's a grouped behavior between certain things. So that we need to actually sit down and do a little understanding manually. So this part is yet to be done. But the first two part, except the analysis, all these things are done. So I think for the next week, I'll plan to refactor the entire code base of what I have done so that it could be easy for a pipeline run, straightforward. And I'll probably ask for Jay to run some tests so that it could be clean and error free. And the second, I'll try to understand. I'll write the next part of the sections, that is methodology and all, and bring some analysis and results based on observations that I have seen during this process, and bring some tabular results and visualizations into the work. And I'll try to bring out an entire pipeline of the diagram using a single unified diagram. So in generally in Elsevier and all, they actually have a first page diagram where the diagram, the figure or the diagram explains the entirety of the work. So it's like a holistic framework what we have done, it shows in a figure. So probably we can think of doing one figure too like that. So that's all for this week. Any suggestions?
That's great. Thank you. So that you're working on your documentation and you're kind of finding a stopping point for the project. Okay.
Yes.
Good. And are you gonna put visualizations and so you're gonna put this in the repo with the visualizations and the software.
And is there any suggestion that I could share this work with you so that you can?
Yeah, you can share an overleaf project, I think. So if you can send me a link to the overleaf project, I think you can just send my email or something. I can look it over. And or you can just send me the PDF too. I can do that. But okay, thank you, Lalith. That's good. Yeah, we can move on to Vidhi, I guess.
Yeah, hi.
Hi.
So I'll just present. So, right. So last week I added 2 new features, which were dropouts per step and tasks per step. So these 2 new features actually allow us to manually change the number of dropouts per step we had, and earlier it was fixed to 2 per step, but now using this feature we can change it. And similarly, the tasks per step was fixed to 3, but now we can change it. So I'm just giving a recap of what I had done till last week. So, like the benefits of the changes that we observed by adding those 2 new features, so that the users have dynamic control and it's more of a realistic simulation. And apart from that, like some things about testing and high dropout and everything. And the most important part is the improved user engagement, because I even added the visualization, and of course, like now we had more parameters to like work on, like not work on, but then we can see manually. So this was the difference in the resilience quotient that we saw. So the first case, the first graph that we see is where there are 2 dropouts per step. We see that it initially starts with 1, it goes high because it learns how to manage, and it goes low, it goes below 1. But if the dropouts per step is less, if it's 0, then this never comes in question. But if it's 1, then it goes up and it comes down, but it never goes below 1, or it never even comes close to 1. So this week I added a new feature, which is actually a new metric, and this metric is the reassignment overhead. So it measures the proportion of tasks that had to be reassigned during a process or simulation. So like we saw that there are 2 agents that drop out per step, and we were saying that some tasks will be assigned to them, like if some tasks are assigned to them in that step. So what happens in that case? So those tasks need to be reassigned. So this is the metric that will check on it. So what I've defined it as is number of reassigned tasks and total tasks assigned. And it's very important because it evaluates how the tasks are being allocated. And lower arrow means better initial assignment, and it helps to identify coordination. So the values are 0 or 1, and 0 means there's no allocation. That means all the agents that were given the tasks, they do it well, and none of the agents that were assigned tasks have left. But if it's 1, means that the agents that have left have been assigned the tasks again. So here, like the benefits of the changes that we have observed, that we know our simulation works well because at every instance when the agent was assigned a task, it was also being reassigned. Like with the agent which was dropping a task which it was being given is being reassigned. That's why we get the value as 1 always, because there's no task which is not done. So it's somehow reassigned and the task is done. And then, yeah, these are the 3 graphs where we see the harmony index slightly increasing from around 0.4 to 0.6. We have the resilience quotient, which increases and then goes down. And yeah, the reassignment overhead. And then I updated the README with the 3 metrics in detail, where I've spoken about how, like, what each of them are, what their formula is, and the range. Maybe in the next week I can add more detailed stuff about what is a good range and what is not a good range, and how much it should be, as I've explained in the PPTs previously. And yeah, I had a blog for that. That's it.
All right, thank you. That was very good. Yeah, I like that you're continuing to develop it and develop things, metrics and things like that, and testing them out.
Mhm.
So it looks like Sarah's here. I don't know if she wanted to comment on Vidhi's work or.
Yeah, hi Vidhi, and hi everybody. So good presentation from both Lalith and Vidhi. I had like one doubt for Vidhi. Basically, a little while ago we had talked about like the different types of agents. So we had talked about kind of trying to see if the way you have defined the agents matches any kind of existing literature, or if not, if you were planning on defining those yourself. So have you figured, like, since you're nearing the end, that's something I would like to see, like maybe you formally define it or try to connect it to some type of literature.
Like I have most of it in my mind. Like I've written it down in a document roughly, not anything fair, and I've kept it for like the next week because it's almost approaching the end. And then when I completely define the README well, and like Lalith has a paper, I might write a paper too, or some formal documentation where I will mention everything about these agents and where I got the inspiration from, and the ones that I have defined on my own, everything in detail. So, like, while I'm writing it down in this week, probably in the middle of the week, I'll send you my first draft, and then you can let me know, like, wherever I can make changes. And then by next week, I should get most of it done. Let's see.
But sure, you can send it to me.
Yeah.
Thank you.
All right. Thank you. All right, that's great. Thank you, Vidhi. Thank you, Lalith, for the updates. Jesse, I don't know if you want to give an update this week or what you want to do. But the floor is yours.
Yeah. Can you hear me okay, by the way?
Yes.
Mike's a little falling over. Yeah, I'll give a very quick update on. I wanted to share a few things that came over the last few weeks, and then also something that came up yesterday that I think is good to consider, especially for, this group is open source based, but I think there's a few key terms and a few concepts I think would be very prudent to impart. That some of them I've known for a while, some of them have been reiterated as part of my recent business type trainings. I'm taking a micro MBA course that's almost done. I don't know if it's what I call it course or whatever it is. It's an atypical degree, but I found it very useful. And a specific conversation from someone who does a ton of actual building last night on Twitter, which really solidified certain. It was a very practical, real life example of what we were talking about before. So I'm going to attempt to share this. Yeah, it should just be my Slack screen.
Yes.
Coming through. Okay.
Yeah.
Right. Cool. So it's really just this. And I'm going to start with innovation. I'm going to talk about what a moat is, and I'm going to talk about this quote specifically. But just to set it up, I say this here in terms of. I say this here in terms of essentially, innovation came up last week, and innovation means very different things depending on what space you're in. And in the space of business and MBA type stuff, and talking to people running organizations, innovation can mean this, which is sort of this widening the value gap. There's different examples about, and I sort of apologize to like heavy open source people or Bradley, but there's probably a certain amount of cringe here, but I'm trying. Hopefully, it will lead to get into explain it this way. But the value gap is sort of how much it costs a firm to make something or deliver a benefit, and how much value the buyer is receiving. So you want to make this number get bigger, $50, $60, whatever, where it costs $20, $10, $5. Let's say by widening the value gap according to certain takes on innovation, you are innovation. So sustainable innovation in certain terms means value creation, or begins with value creation. And innovation solves problems, meets unmet needs at once, and all this other stuff. So this is an excerpt from a specific discussion, but just a super introductory crash course with very little warning. Like when you hear innovation, it may mean widening the value gap. So that's one thing to do. One thing to keep in mind. Now, from going from innovation to moat, which is what I'm going to actually get to with this thing, the moat is the competitive advantage. So under Warren Buffett, investor guy, his big thing was understanding the competitive advantage at hand, and what is the durability of that competitive advantage? Like you might be the only person in space or have like a really great advantage, but can someone undermine it? I mean, if the real world application is right now are the bidding wars for talent. Like, is your competitive advantage talent? Well, are you willing to play the big money game? That just check for a second. Are you willing to play the big money game that's like popular right now? Sorry, it's just flying to that question. So you know, yes, I won't go too long into this, but basically, operating strategies about creating viable, realistic moats. So, like, how is what you're doing from an operational level or building it out related to your moat or the means by which you're sustaining a competitive advantage? And just to bring this up for people who, what does competitive advantage really mean here? Maybe it isn't your concern primarily in an open source world about competitive advantage. But again, I think it's important for open source folks even to realize, like, when you're interfacing with anybody who is building something, or especially if they are dealing with for-profit or proprietary stuff, like they're either going to be concerned about this or they're going to have to answer to somebody who might be concerned about it. So I know these terms can be important in that sense. So competitive advantage is the thing that you can do that makes you stand out, that makes you, like maybe an easy example is like, what's the competitive advantage of Uber or Lyft compared to taxi cab, right? In essence, it's some of their structuring about, they have a great app, but also like they have contractors versus employees, and the structure, how they get people to buy into stuff, and then Lyft added certain things to that, and what there's a whole market stuff and all this other things we'll get into, but sort of what makes you unique and how easy is it to duplicate that or just hack that or steal that or repurpose that, which matters for investors and other things like that. Where am I really wanting to go with this right now, though, is basically this. This was just randomly, I saw this randomly on the Twitterverse yesterday, and I was like, oh, this is a really insightful comment. So let's read it. Let's talk about it. A defining trait of platforms that mature into ecosystems is in their ability to externalize high variance customer specific work to third parties such as developers, partners, and integrators, while becoming more valuable and defensible by controlling critical interfaces, the choke points, such as APIs, data models, and marketplaces. Companies that do not make this transition often remain dependent on large internal teams of forward-deployed engineers and bespoke services, which grow revenue but limit operating leverage. In successful ecosystems, incremental software efforts shift from long-tail, high-end variance implementations to strengthening the core platform by hardening primitives, standardizing interfaces, and expanding extensibility, so the ecosystem absorbs variance and the platform compounds. So if this doesn't make a lot of sense, that's fine. This is like pretty jargon, deep in the weeds, people building things. I'm gonna try to pull up. I can't easily share this, but like the person who's Jorg. Jorg is like done a lot of building. They've done things with Meta, Uber, Beyond Deck, Google AI, Cruise. Like they've done a lot of like actual deep in the weeds stuff. So they're coming from. This is pretty not really hit list talk. It's pretty niche talk. But some things to take away here are, as whatever you're doing grows, and this is maybe different. This is maybe not necessarily a challenge for this group. A lot of our projects are smaller projects, and whether or not they have a future, it's one thing. But like some of it is building on a large history of sustainable development, sustainability, and open source sustainability. Obviously, DevaGraph and DevaWare have been there for a while. But we're not necessarily making this a huge thing to sell and make into a profit. But as things scale, it's useful to consider, in this case, Jorg is talking about, choke points, critical interfaces. And essentially, as these things change over time, like you can externalize some of this work, but are you losing some of the key stuff? So if we go back to the moat concept, like what can you safely like have a bridge across your moat. And for those that don't know, I should say like a moat is something you build around a castle, like this water thing. So it's something that it's an inherent defense structure that protects your valuable asset, like the castle or your valuable, whatever it is that you're doing. So it's a big defense barrier. I should probably say that to start with. But if you want to extend things outside of sort of the membrane, inside and out of this protected space, what can you do in that light that may be of use? So particularly thinking about these things that are third, what can you easily do offload to a third party without losing control of these critical interfaces? Like how is your API going to work? Are you what's your relation to like its marketplace, either of ideas or actual like the ways that transactions are happening? So when you can't externalize things as your stuff grows, you're dependent and locked down onto certain things, onto maintaining a bigger internal team to do a lot of that work for you. So my last point on this, and I don't have an easy way to show this right now, but I'll do this just for semi-dramatic flair. One of my last point on this, and if for those that ever are going into like startup space and whatnot, is a key thing from NVIDIA and the Inception program. The Inception program is, I've done work with them or almost done work with them because what I was doing before didn't quite fit it. But I've been in spaces where like the director of NVIDIA's partnerships was talking some stuff in Boston here a while ago, and one of the things he said is like, it is so critical right now to understand like when you're building stuff, it's a matter of building out the best thing that you can do and knowing when to partner and when to offload stuff, because that's sort of the name of the game right now is, as you go into the world, like you have very specific things that you want to do and specialize at, but then what is the things that you can partner with and what can you safely partner with? But sometimes that might be, in the context of this super deep in the weeds post from I said, what's your moat here? But in the context of the super deep in the weeds stuff, understanding where might these things appear. So I know that's maybe way more out of tangent than we normally talk about and thinking about something you might want to do in the future. But it's kind of good to keep in mind now to think a little bit of, as you're going into innovation startup worlds, the different ways people talk about innovation. What is the moat? How do you what is competitive advantages? The kind of unsightly things that might be required as you do more things in the world to make certain things. I just wanted to do a brief tour of that and let it be. So if you have any questions, was that sharing or not?
Yeah.
I don't think the Twitter screen share. I don't think
everything did.
Okay. If any questions, let me know. Otherwise, that's I wanted to just mention those things too. You can be aware of them.
Oh yeah, that's great. Thank you. In my project management course, I talk about like the advantages of automation and when to automate and maybe when not to automate. And then, of course, there's the third-party partnerships, which are kind of similar because you need to have, a good rationale for doing things like that. You can't just do them as you might save money in the short term, but you might end up spending money in the long term for things like that.
Yeah, and it's sort of like balancing the control of what you're doing and staying true to the mission, and then trying to put a marketplace like there's a whole conversation. We don't have to go in this right now, but like what is GTP5 really trying to do from OpenAI?
Yeah.
Like I forget. I don't think we talked about this last week or not. But just super. It's very easy to talk about here. I'll share this very briefly. Like this is, this Emil Torres is someone who does a lot of criticizing of, big tech and someone that I met in person a long time ago, and stayed in touch with some. But this is sort of, we don't now. It's like, I don't know, open AGA, or not a really useful term, which is sort of like ironic. But and I'm saying, like, I forget who said this, but someone in here was like, yeah, OpenAI seems like a product company now. So our LLMs reaching maturation and all this stuff. So it's like, as this is another huge can of worms I'm not trying to open up all the way right now, but I'm mentioning in the sense of as your stuff develops, like, are you this, in the case of OpenAI and such, they have a very particular big tech still has to appeal to the public in certain ways. Like they have to do that to kind of rationalize what they're doing and get money to people to buy their stuff. So what I'm saying here, what I mean with LLM maturing and all this stuff is, as your technology, as whatever you're building either matures or you're seeing the limits of what it can do, your emphasis in terms of product company, your emphasis changes, and kind of going with what Bradley was saying, what I was saying earlier about like your mode and competitive advantage. Is like you have to be very strategic and make risk. There aren't really usually perfect choices, and so it's like you have to make these critical choices as you're developing your product or company or whatever you're doing, your idea, in terms of what can you automate, what can you outsource, or like OpenAI is maybe doing a total, well, yeah, I don't even know about AGI. We don't want to deal with that, which is what kind of makes me laugh. But it's sort of, maybe now ChatGPT 5, like, yes, it can do some great things, but it's also a huge like user interface upgrade. Like it's reducing the choice of customers. There was a really great Sarrah does really. She was one of the MIT AI Ventures winners, but where's her recent one? She did a good little thing about like this post. And I don't know if this is showing up very well for you here. It's kind of, but basically saying one of the things they did is like one of their biggest pushes was making their UX a lot more appealing. So it's like, she criticizes a lot of like UX and behavioral stuff in like AI products or whatever. And so she's like, this is what a great AI product design looks like. So it's like, they made a huge change from all this really clear, weird selections to this one very, very, I would say Apple, very reduced, minimal, happy, fun, clean interface. You just type here, you don't deal with this stuff anymore. So she's saying, and so that's why I'm saying, as in this context of, more of a product company now, they're focusing a bit more on how does the market absorb, I don't want to say absorb, but how does the market perceive them, and how do they fill these niches and make their product more and more and more accessible, more and more like user friendly than just necessarily, product enhancement, like performance. And there's huge debates about is GTP5 doing, light years and jumps and way ahead or not, or is it just kind of, a better wrapper and maybe a little bit more making it more clear to the user what it's doing, as opposed to doing a whole lot of things differently. So that could be for debate and discussion, but yes. So any other comments?
I think that's it for now.
Yeah, fun little tour of like other stuff. But I'm happy to kind of come back to the special program, and yes, I'll follow up with all this. Yeah.
All right, that's good. I guess Morgan, you're the last person that came to. Would you like to give an update, or are you in a position to give an update?
I am still driving. Sorry.
Okay. Well, I'll get into my thing, and then maybe after that. Okay, so I wanted to bring up, and I know this is for our GSoC students, but more broadly for the organization. We're coming up on the end of GSoC. So projects are, according to the schedule, projects are due Monday, September 1st. So that is roughly 2 weeks from now. I think it's a couple more days than 2 weeks. But the point is that you need to start getting to that endpoint for the project, and getting it turned in, or at least getting it to the point where you have your submission materials in place. So that means that you need to find a place to stop doing development, and then have your README reflect that stopping point, and then have a place where you can maybe put issues for next year, or for continuing the project if someone wants to pick it up and run with it, or if you would like to do that. We need to have a list of issues, and if you know how to use GitHub issues, then we can use GitHub issues. So if you go into the repository and you go to the issues tab, you can post some issues there. They're numbered, and just be descriptive enough so that people know what the thing that needs to be done is, the task. I think if you're working in open source sustainability, you probably have hopefully a pretty good idea of what issues look like. But in any case, that's where we want to be in about 2 weeks. So we want to be at that point where we can submit a link to the final submission form, and then on the other end they're going to open it up and inspect the work, and that's what we want. So we want to have that, but we also want to have enough information so that the repository is useful to other people. So we don't want to just kind of leave things cryptic and nondescript, because that can, that reduces its reusability. We can't necessarily go back to that repo next year or even next semester and expect to be able to pick up and move on. So again, I want to make sure that you know what the due date is for that. Okay, so this past week I attended the BICA conference. Actually, it's last week, I guess. It was a good conference. I participated as usual. It's an online conference, and BICA stands for Biologically Inspired Cognitive Architectures. And so the lab actually has been going to this conference for several years now, and we've been presenting every year. And we have sort of this, I don't want to call it an ecosystem, but sort of this whole constellation of things that we've been doing over the past several years. And I wanted to review those in the meeting. So let me see. Okay, so we've been contributing to this conference. This is BICA AI, so it's Biologically Inspired Cognitive Architectures. I did a short overview at last week's Saturday morning NeuroSym meeting, and that's on the Orthogonal Lab YouTube channel. So if you want to go and find out more about the conference, you can find out there. Basically, it has an interesting history. It's been around for maybe about 15 to 20 years. And it kind of grew out of these cognitive architectures that have been around since the 1980s and 1990s. So the cognitive architecture is where you approach AI from this perspective of cognition being the key element, but also biological inspiration. So you build these large architectures with boxes and arrows that have different cognitive functions, and then you kind of build models around that. So you enable these cognitive architectures to do certain things, different information processing tasks, and you can incorporate like modern AI components. You can incorporate what they call neurosymbolic platforms, so where you're combining neural networks and symbolic models. So you can do all these sorts of things. They're very flexible, and it's not in the mainstream of AI, but it's definitely it's a different, when you go to the conference, it's a different take on AI. if you've ever been to NeurIPS, or if we've reviewed like NeurIPS and ICLR and how those conferences are, and the kinds of papers they have. It's a very different feel at this conference. So the first time we participated was 2021. These are all virtual participations, but usually what they do is they hold it in a physical location, then they have a virtual component. And this, in 2021, it was held in Kyoto, Japan, and then also a virtual component too. And we presented on Gibsonian information. So this is back in 2021. We did this presentation, and of course, every year we've participated, we've also published a conference paper on the topic. So I'm going to have a list of papers on the Representational Brains and Phenotypes website that kind of go over this. So Gibsonian information, for those who are unaware, is a form of ecological information processing where you have this external communication channel which has some distribution, usually a Poisson distribution, that describes the spatio-temporal distribution of sensory components. So it could be like things to see, it could be like visual features, they could be auditory features, they could be features where you have to touch an array of things. And the idea is that it's this naturalistic sort of embedding. So you have all these things out in the world that you can interact with. There's some distribution of things. And you bring them into the model, into the internal communication channel through sensory apparatus, some sensory apparatus. It could be sensors on a robot. It could be your sensory organs. But nevertheless, this information comes in, and it's all time dependent, but it's also spatially dependent. There's this communication channel which merges these channels as well, or merges the external sources as well as processes the information. And then we have this decoding, and that's what we mean by Gibsonian information. And we can measure different aspects of the information as well. Okay, so that was the 2021 paper. We have a conference paper on that. We also have an archive preprint in more detail about what Gibsonian information entails. The 2022 conference was held in Guadalajara, Mexico, but also virtual. So this was this paper here, which we presented, layers, folds, and semi-neuronal information processing. So this grows out of this work that our group has done on what we call metabrains. So we presented on metabrains in different venues. So metabrains are these layered models that, and I'm not showing it here, but basically the different layers are different levels of representation. So you have a bottom layer representation that might be like a neural network, which is a minimal amount of representation, meaning it's just a network and you push data into it and you can discover patterns in a bottom-up fashion, and there's no representational framework, or very little of a representational framework to work from. Then you have these other levels above it, which actually have progressively more representational power. So you might have a neural network on the bottom, then you might have some sort of dictionary or mapping in the middle, and then eventually you might build up to like a symbolic model on the top, where you're using different types of symbols and mapping things to symbols. Basically, it's an approach to build these neurosymbolic models, but it's done in a way that sort of mimics biology, or at least the way that things that get processed, say, in neocortex or in other parts of the brain. In neocortex, we have these 6-layered structures. In other parts of the brain, we have these 2-layered structures. And a lot of organisms, they have maybe 2-layered structures that predominate in their brains. So these are biological systems, or they mimic biological systems. And in this paper, what we were doing was exploring that metaphor further. So we actually built these different types of structures where you have the layers, but they're arranged in this sort of topology. So in the paper, I think we talked about the gut, which is in neuroscience known as the mini brain. and thinking about the gut as being this layered information processing organ where, it's not the brain, but it has like these different layers of representation where you have things coming in from the different, like the enteric nervous system and other nerve endings and things like that that are sensing things in the local environment, getting information from the rest of the body, and integrating that information. And so that's what this is, kind of illustrating that idea that you have not only these layers, but you have this topology. And so this is very much part of this embodiment program. So we're thinking about this also in terms of embodiment. We're putting models into the world in a way that's embodied in a larger structure. And then this down here just shows like a compositional approach to this, where you're putting these models together and putting these layers together in a developmental context. So that's kind of what that is. In 2023, they held BICA in Ningbo, China, which is, it was also a virtual component to it, but, this was I don't remember the theme. They usually don't have a theme. They just kind of hold it either in conjunction with another conference or a standalone conference. So this was, I think, a standalone conference. And at 2020, in the 2023 meeting, we had this paper, Super Performance, Sampling, Planning, and Ecological Information. So we're drawing a little bit from the Gibsonian stuff, but also drawing from this other idea of super performance. And what super performance means is that you have a nervous system and it generates behavior. And the nervous system has a capacity for sampling the environment, and it has a capacity for planning like movements in the future or things like that. So the metaphor we used was a person trying to swat a fly or capture a fly in their hand. The fly has a nervous system or a visual system that has a much higher sampling rate than the human visual system. And so you're tracking the fly, and you're able to track the fly's movement, and you have to coordinate your hand to catch the fly. And that all happens at a certain speed because your muscles are limited by a certain speed of generating movement and power, and your visual system is limited by its own resolution, whereas the fly has a different sampling rate and a different resolution available to it. So flies are higher samplers or maybe even super samplers, whereas humans tend towards a super planning rather than super sampling. And the idea here was that we explored these different regimes of super planner, super sampler, sort of an optimal trade-off between the two, and then a relativistic regime where you can have both super samplers and super planners. And so that's that was that paper, and was just thinking about how you might have like agents that are super planners and super samplers, and how they might compete in the same environment, or how they might build off of one another in the same environment. And I think we introduced pursuit evasion game, and we presented some other types of coevolutionary models to show how that might work. So your agent is actually doing these sorts of things. They have this planning capacity or the sampling capacity, and they're interacting with each other. So you could use this for like social robotics, or for putting together sort of a super cognition, like a collective cognition or something like that. Okay, so this is an example of what I was talking about before. This is a figure from the talk where humans have a visual sampling rate of 16 hertz, or maybe a little higher than 16 hertz. Drosophila, which is the fruit fly, has a visual sampling rate that's much higher, between 60 and 100 hertz. And then Glossina, which is another insect, samples their environment between 85 and 205 hertz. So you can see this variation in visual sampling, and they exist in this continuum of sampling rate. And I know they have different types of eyes, but those different types of eyes enable this sort of super sampling versus maybe not super sampling. And then humans have this capacity for planning, which is maybe higher than in insects, where we have, learning memory apparatus. I mean, I don't know how to, we didn't quantify that in this paper, but it sort of goes on this continuum as well. So then in 2024, BICA was part of the AGI conference, which was held in Seattle. And of course, we had the virtual component. And this is where I presented alone on the allostasis machines idea that we've been developing over the last several years. These are what these little allostasis machines are, these agents that maintain what we call allostasis, or they exist in a dynamic environment and they have to maintain an equilibrium, but it can be at different states. And so, when you perturb an agent from its normal behavior, it can adapt to that, but it adapts to different stable states as you perturb it. So it's always finding a new state, and it's able to exhibit this great resilience and robustness. And so the cognitive model here is incorporating this allostatic component, or this allostatic response, into an agent that uses some sort of simple, intelligent program. So that's what this was all about. And we presented this back in 2021 to a different type of group. So we were applying it more to human-computer interaction. In this case, this is more about the cognitive architecture. And so this is an example where you have sensory information coming into this internal model, which is the intelligence. And then you have this map where you have this trajectory of output, and you perturb the trajectory of output so that it either, the trajectory becomes unstable or it finds a new state. And so our trajectory is able to recover and find different states, stable states. And the idea is you develop an internal model that's robust enough so that you never get lost. You always find a stable state. And this can be stated in terms of sampling rate. So you sample your environment at a certain rate, and you find points in which you have different dynamical systems properties. And that's pretty much what that paper was about. So we've done 2 papers on that topic. And, again, we're always trying to develop new techniques for these different areas. And then finally, this year, we presented this paper, The Augmentation of Intelligent Agents for Human-Machine Super Performance. So this is kind of building on the talk from 2023, where we talked about super performance. And if you go back to that, we have super planning and super sample, or we have this relativistic regime where we have a high sampling rate and a high planning rate. And so that's what we mean by super performance, to have both of those at the same time. And what we argue in this paper is that performance, that super performance, is achieved through what the cyberneticist W.R. Ashby called an intelligence amplifier. So he proposed that you can amplify intelligence by having a certain baseline intelligence, interacting with the environment, and getting positive feedback from the environment that would improve the level of intelligence, with bootstrap intelligence in an agent. And so, it's something that is, it's like this approach that's called intelligence augmentation. So instead of building an AI where you try to build it of the highest level of intelligence, you interact, or you have an agent that interacts with a human, and then it learns from the human, and the human learns from the model, and there's this mutual bootstrapping that happens. And in this case, there's a world model that exists. So there's this intelligent agent that's doing this with a world model. So it's this intelligent agent that might be like a neural network, or it could be a biological intelligent agent. And they're interacting with this world model, which is this representation of the world. So you have this representation of all things you might encounter in the world, and then that world model gets refined, and the intelligence of the intelligent agent gets refined through these measurements of intelligence that we propose in the paper. Okay, so that's that. And then I just wanted to finally show this map of our BICA accomplishments for the past several years. So we have this theme, layers, folds, and metabrains, which we've done a number of presentations on. We actually did one at Artificial Life in 2020. We did another one at a agent-based modeling conference in 2021. We did one at Neuromatch 5, BICA in 2022, and the EI workshop, which is the human-computer interaction one in 2022. Then we have this theme of Gibsonian information we presented at Neuromatch 4, at BICA, and in an archive paper in 2024. We also did the allostasis machines work, which was presented at SIGCHI in 2021. I'm sorry, EI workshop was not human-computer interaction, it was embodied intelligence. So that was in 2022 for the layers, folds, and metabrains. SIGCHI was human-computer interaction in 2021 for allostasis machines. Then we presented that at BICA in 2024. And we also presented that at the Immerse conference, which was a VR conference in 2024. And then finally, we have the super performers, which is kind of an emerging area. We presented at BICA 2023 and BICA 2025. So this map is available on the orthogonal Research and Education Lab website. It's in the carousel of projects. So just to let people know kind of our activities on that and where we stand. Okay. So we have any questions or comments?
Review of things. Like it's nice to see everything in sort of one like session of movements through what we've been doing.
Yeah.
Check that out more.
Yeah. Now the reason I'm presenting that here is, well, A, I wanted to give an overview of the work, but B, I want people to think about when they do a bunch of work, I want them to think about how that fits together. So, we're doing this, we go to this conference and it's this general theme and we keep producing work, different types of papers, and how does that all fit together into a grand scheme? Like how would we say use them together? Now, interestingly, this work on super performers from this year referenced a lot of the Gibsonian information work. So you're going back and you're referencing the different components, you're building on that. So we have, a lot of opportunities for developing the software, because a lot of these are sort of concepts and theoretical ideas that need more development and things like that. So that's something that is the open source part of that, but also, kind of the implementation of the synthesis of these ideas. How do you bring them together? Yeah, go ahead.
It's a tangent, and it's one that I've spoken about often, and there's two parts to it. One, yes, I'll speak of myself only. As I have gone through my, academic-ish career or whatever, it's become very clear to me that this synthetic across time view that you are working on as a researcher or developer or someone leading a project is critical and almost inherently going to be, I don't want to say dismissed, but not centered. And where I'm going with this, Bradley, is like our kind of, every now and then we bump up on the idea of conferences are almost inherently designed in these very discrete chunks of, okay, present your stuff, and that's great, and then we don't talk about it, don't synthesize it, and don't build anything don't have any like actual continuity of developing your ideas. I would summon Amanda Nelson in Philosophy Talk of let's refine ideas over time instead of just kind of making your little a la carte discrete chunk of it. So where I'm going with this is, it is important, and many times it's sort of like almost like a temporal form of documentation across years, because you may be the only person, you and one other or two other people may be the only people who actually get where it's going. And I say this not to be you know, oversharing stuff, but this, I literally had this, I saw this moments ago. But why does this matter? Like, well, and if you really want to zoom out and get to, you know, why does it matter? Like, very intelligent people years from later may be trying to understand what you're talking about.
Yeah.
Like we're reading Alan Turing's 1950 paper about, you know, it mentions, I forget, it's like computing machinery, but it mentions the imitation game and all this other stuff. And it's an interesting paper in general, but like that's a paper that's kind of set in a very specific context. It talks about, you know, digital computers and sort of universal computation. It's potentially this landmark. It is a landmark paper, but like why and what was it trying to do? So it's like there's this big mystery around it, because how serious was he? Like these are like very informed people, Kevin Mitchell, Middlebrook, Sean Mannion, all these people here like trying to understand what's the context of it. What was, you know, what was said was it part of this dinner party series that Turing and other people were at to try to talk about all these different things about it. So what I'm getting at here is like, there's a very, if you don't write, and I think this is very, very important for everybody right now, honestly, because there's so much pressure against narratives in general. But like, if you don't attempt to maintain the narrative and context of what you're doing across time, it probably won't happen. And if you want it to be something you want to talk about like sustainability or whatever, you know, how do you do that? Like I was also, I guess I should mention, I was also at the Public AI conference this week, which is a very small conference, but run by the people that do Public AI Summit, excuse me. It was run by the people that are doing the Data Rendition Project and the AI Pedagogy Project. You know, and it's kind of come up there too. It's sort of like, how do you build, you know, these things that matter. The Data Nutrition Project itself is sort of this effort to, you know, label these data sets. We've talked about this before, I think, earlier. But these efforts to make data sets more accessible, that you can interpret them and know more about them beforehand or time before you even do an exploratory data analysis, just right from the start. You label it and you can build on it. So we're kind of doing this here, but then also what Bradley's talking about is like, for your stuff, for your body of work, for the history of your ideas or you or your group are building over time, like creating the narrative and creating some like not just documentation at sort of the micro level, but the macro level documentation. It's kind of important. And like we were saying, there's an element of if you don't do it, you know, that it's not just sort of, I'm trying to articulate this, but it's not just like, oh, it's a nice to do thing and yes, promote yourself, but like there's the things you're talking about could become, and yeah, we're not all going to be Turing writing papers in the 50s about a field of development that hasn't happened, you know, that's going to emerge over the next 7,500 years. And, you know, I appreciate Bradley for doing that specifically. I'm still, this is maybe directly to Bradley and Morgan, or anybody else who was interested in this topic, but like, I'm very interested in that time, either across an individual or groups. I'm reiterating that specifically because I think I'm going to plan in 2026, where I would like. I'm very interested in how we could try to do this differently, and at the very least, if we're not going to change how conferences work, I think Bradley modeling what just happened is an important thing to do. So, a practical step.
All right. Yeah. Thanks. That's great. I'll have to think about that more. So
that's tough. Okay.
Yeah. Looks
we're
like
past.
yeah, we're past, but we had a couple of things here. Yeah, just some discussion here about the Lalith's documentation. So yeah, we'll keep working on that. All right. Yeah. Thank you. Yeah, I'll drop in the materials in the Slack from today.
Yeah. And for Vidhi and anyone else, like if anybody wants to, you're always willing to just directly ask questions on a specific thing, or just have us look at stuff in general too. Like this is sort of the wrap up period, and it's gonna be, there's choices to make about what and how to do certain things, but we're here.
Yeah. All right. Thank you. Have a good week.
Take care, everybody.
Take care.
Thank you.
Thank you. Bye.
Thank you for the discussion.